Our other type of word problem is so simple that if textbooks and math teachers taught everyone units, this problem could appear in a basic math book. It's not really an algebra problem, or it doesn't have to be thought of as an algebra problem. Certainly not a college algebra problem. But here it is. It shows up in your textbook. And as usual, according to script, the textbook, like all other textbooks, does it the hard way. And so what in the world am I talking about? You don't need X's and Y's. You don't need formulas to solve a problem like this. So let's look at it. All right. Pump A can fill a tank in 24 minutes. Pump B can fill the same tank in 30 minutes. If both pumps are used, then how long would it take to fill the tank? All right, now if you look at that and you think, well, it'll take 27 minutes, do that on a test or a homework for me and you're going to get 0 credit. To say that it would take 27 minutes, which is the average of the two pumps, is really overlooking something serious. Because if one pump only takes 24 minutes, if the second one is brought in to help it, that's going to lower the time it takes to fill the tank, not increase it. So the answer has to be something less than 24, doesn't it? Has to be. Okay, so how can we do this without a formula, without a chart, without all the other stuff you see in the commercial textbooks? And units are the key. Think about the units. But the other insight here is to think, well, what is the least common multiple of 24 and 30? Think in terms of like a lowest common denominator. And 24 and 30, the smallest number that's in common with both would be 120. 120 minutes. So what I'm going to do is say, well, let's pick a convenient number to work with. And convenient here is the least common multiple. 120 minutes. What happens in 120 minutes? All right. If these pumps are running separately. All right, so in 120 minutes, pump A fills. Now if we take the time, 120 minutes, and multiply by the rate at which it fills. Now it fills tanks at the rate of 1 tank per 24 minutes. 1 tank per 24 minutes is the rate at which it's filling. And if I multiply by the time, 120 minutes, then the minutes units cancel. I'm left with tanks. That tells me how many tanks it fills. Now 24 will divide into 120 5 times, so it fills 5 tanks. And you can start to see why I chose 120, because I'm not getting fractions or anything like that. I'm just getting nice round numbers here. All right, pump B fills, and same amount of time, 120 minutes, and it fills at a rate of 1 tank per 30 minutes. 30 minutes. I'll try to make this a little more legible down here. And again, the units cancel. And my 120 was chosen for convenience, because 120 divided by 30 is 4. 4 tanks. Now I'm writing all this in words because this is how I'm thinking through it. But what do we know? In 120 minutes, both fill at a rate of, how many tanks do they fill in 120 minutes? Well, they fill 9 tanks. 5 plus 4, so 9 tanks per 120 minutes. And what would this be? Now this is a little funny. 9 tanks at 120 minutes. I need to divide 9 into 120, so that's 1 tank per 120 over 9 minutes. There are other ways of looking at that. If you had sort of like 9 tanks equals to 120 minutes. And divided both sides by 9, you would get 1 tank is this fraction, 120 over 9 minutes. And let's see, what is that? 12, 13, 13 times 9 is 117, 13 and 7/9 minutes. So let me write my answer. It takes, what was my answer? 13 and, doing all this in my head, that's part of the problem. 13 and 3/7, 3/9. If I divided both by 3, I would have 40 over 3. That would be 13 and 1/3. 13 and 1/3 minutes for both pumps to fill a tank. Okay, if you wanted to call that 13 minutes and 20 seconds, that would be perfectly fine with me. 13 and 1/3 minutes for both pumps to fill a tank. Now, to me, that's a pretty reasonable answer, because what if both pumps ran at 24 minutes? And if you had them both together, you would expect that both running at 24, that would cut the time in half down to 12. If both pumps ran at 30 minutes, together, two of them together would empty in 15 minutes. So my answer should be between 12 and 15, shouldn't it? And indeed it was, 13 and 1/3 minutes. So I'm very confident that that's probably the right answer. All right, so look at how I did this. Nothing but units. Do you see algebra there? Any x's to solve for? None whatsoever. So I hope you join me in thinking about these problems this way. I know some students will just go to the book and find a formula and just plug numbers in. And you know what? When they get out of algebra, they won't have any earthly idea how to do these problems, except that they're supposed to look up a formula somewhere. So what have they learned? They haven't really learned anything of value. You know, learn how to think. That's what you're here for in college. That's what's important. And so I want you to see how to think through these problems. And it's wonderful the way that the units just you know, do the work for you. All right, we'll do one more of these.